Welcome to 30 Facts videos about the universe that you will probably hear about for the first time. I can list the most interesting facts in this video as follows. If there was air in space, what would we hear? What will happen when the expansion rate of the universe exceeds the speed of light? What could we do if we exceeded the speed of light? Stars lost at the edge of the universe. Interesting information about quantum physics and water. Comparison of the Sun and the largest star, Coes. The relationship between the Tingling on television and the universe. Supermassive black holes in the centers of galaxies. Ghost particles from the Sun. Interesting information about the solar system. We will look at the most interesting facts about the universe. The formation of elements, the oldest light, giant gravitational lenses, the evaporation of black holes, what it will look like when Andromeda and the Milky Way collide, what the moon smells like, and more. So let's get started. 1. The largest star we know of is Coes, whose radius is 1708 solar radii. We can use this to calculate how large it would be if it spontaneously replaced our Sun. According to Wolfram Alpha, this means that Coes has a radius of 7,941 astronomical units. 1 is the distance between the Earth and the Sun. This means that if Coes suddenly appeared at the center of our Sun, the star's edge would be about half the size of Jupiter and Saturn. 2. The universe is expanding at an accelerating rate. Distant galaxies are moving faster and faster, which means that eventually there will come a time when they will move away from the speed of light and become forever unapproachable to us. Aside from being unreachable, they will become invisible because distances and propagation speed prevent their light from reaching us. The night sky will be completely black and there will be no stars. 3. There are more than 200 moons in our solar system. Most of these moons are around Jupiter and Saturn. Meanwhile, Mercury and Venus are the only planets that do not have a moon, because the Sun has a much stronger attraction than the gravity of these planets. 4. Coca-Cola was the first soft drink consumed in space. On July 12, 1985, astronauts aboard the Space Shuttle Challenger drank Coke to test dispensers and study the behavior of carbonated beverages in space. Applesauce, on the other hand, was the first food John Glenn ate in space during the Friendship 7 mission in 1962. 5. Most stars visible in the night sky are binary stars, 2 stars orbiting each other. 6. There are trillions of galaxies and billions of stars in the Milky Way. In this respect, it is very difficult to even imagine how vast the universe is. But we can compare the Milky Way and Andromeda galaxies as follows. If you shrunk the Milky Way to the size of Berlin, the Andromeda galaxy would be as big and distant as London. 7. The edge of the observable universe looks like the event horizon of a black hole, and every second thousands of stars cross this boundary, meaning that even at the speed of light we will never be able to reach these stars again. Because at the boundary of the observable universe, the expansion of the universe is actually at the speed of light, and everything we've seen so far from these galaxies and stars are their ancient images. Moreover, the fact that everything in the sky is a very old photograph and we will never know what these stars and galaxies look like today is obvious. 8. If you crossed the speed of light and looked at the world from a far distance, you could probably see dinosaurs today. But this is probably impossible to do. We can divide the reason into 2. Firstly, incredible energy is required to exceed the speed of light. Secondly, anything with mass cannot reach the speed of light. 9. If space were curved, this means we could theoretically travel in a straight line in one direction and eventually return to our starting point. But the universe as we see it does not appear to have any curvature. Completely flat. So if the universe was truly curved, it would have to be at least 500 times larger than what we see now to fit our observation. That would be a very big universe. 10. If 2 pieces of metal come into contact in space, they will stick together permanently. This may sound incredible, but it's true. In the vacuum of space, 2 pieces of metal without any coating on them will form as one piece. This does not happen on Earth because the atmosphere puts a layer of oxidized material between surfaces. This might seem like a big problem on the space station, but most of the instruments used there are already covered in material because they come from Earth. In fact, the only evidence of this seen so far are experiments designed to provoke the reaction. This process is called cold welding. 11. We don't know what makes up 95% of the universe. There is dark energy that is causing the expansion of the universe to accelerate. Dark energy is everywhere, even on Earth, but we cannot detect it. One hypothesis says that this is another fundamental force that makes them 5. To test the hypothesis, they put an atom in a vacuum chamber and measure it. We cannot detect this because they think dark energy is suppressed by matter. We can only detect this thanks to the gravity it creates, because dark matter does not reflect anything and does not create its own radioactive emission. Dark energy and dark matter make up 95% of the universe. The rest of the universe consists of the mass, energy we know and love. 12. Quantum physics is the basis of how electrons decide where to move. The atom's electromagnetic forces determine how it forms molecules. So it underpins all these laws and particles and fundamental forces that form a kind of undercurrent on which everything else sits. In my opinion, there is a very interesting substance that we know about other than dark matter and dark energy. This, you ask why? Normally, something expands when heated and shrinks when cooled. When water turns into ice, on the contrary, its volume increases. So how? There is some kind of bending in the structure of the water molecule. This bending only occurs between the hydrogen molecule and two hydrogens. This twist is very specific and unique to this arrangement of these three atoms. The folds in the water molecule cause it to be polar, meaning its shape allows it to dissolve many things. This bending also means that water molecules can form crystal-like solids. It means that crystals of strange water molecules are less dense than liquid molecules. This bending is also the reason why ice floats. Because of this bending in the water molecule, floating ice insulates the water underneath, allowing warm water to grow life. 13. If you could pull two quarks apart, the further away you pulled them, the more force you would need. Even if you manage to separate them, another quark will magically appear next to the other and you will have 4 quarks instead of the 2 you separated. It's a bit romantic to think that no quark can exist on its own without a mate. 14. 3 to 7 different galaxies can be seen from Earth. The Andromeda Galaxy, Magellanic Clouds, Milky Way Galaxy, Triangle Galaxy, Omega Centauri and Sagittarius Dwarf Spherical Galaxy can be seen with the naked eye. 15. At the heart of every galaxy is a supermassive black hole. Active galaxies often emit 100 times more light than normal galaxies. With the discovery of quasars in 1963, it became clear that the light did not come from stars, but from a central region smaller than the solar system. The only conceivable source of energy is matter heated to incandescence as it swirls over a giant black hole with up to 50 billion times the mass of the Sun. But in the 1990s, NASA's Hubble Space Telescope found that supermassive black holes were not an anomaly. Even though active galaxies made up only 1% of galaxies, there is one in almost every galaxy, including the Milky Way, but most have shut down due to lack of food sources. What are supermassive black holes doing at the hearts of galaxies? Were these the seeds around which galaxies froze? Or did newborn galaxies give birth to them? These remain some of the biggest unsolved questions in astrophysics. 16. Tune your television to any channel it does not receive. About 1% of the dance static you see comes from this ancient remnant of the Big Bang. Next time you complain about nothing happening, remember that you can always watch the universe being born. 17. The Sun produces only 1/3 of the expected neutrinos. Give your thumb up. 100 billion neutrinos pass over your thumbnail every second. They were in the heart of the Sun 8.5 minutes ago. Solar neutrinos are a byproduct of nuclear reactions that produce sunlight. Ray Davis was waiting to confirm the standard picture of the Sun when he began detecting them with 100,000 gallons of cleaning fluid in a mine in South Dakota. Instead, it found only 1/3 of the expected neutrinos. This was not only confirmed by later experiments, but also led to the Nobel Prize. Neutrinos are ghostly subatomic particles that exist in a strange quantum superposition. They are like an animal that is a cow, a pig, and a chicken at the same time. As they move away from the Sun, they fluctuate between being electron neutrinos, muon neutrinos, and tau neutrinos, so experiments sensitive to just one type take 1/3 of the expected number. 18. Most planetary systems are different from ours. Scientists are loath to address anything specific about our situation in the universe. Special is unlikely, typical is likely, but the discovery of planets around other stars has created a headache. None of them are like ours. All planets have supercompact planetary systems in which they are closer to their parent star than Mercury. The innermost planet of the solar system is to the Sun. There are Jupiter-sized planets that must have migrated inward. There are planets in highly elliptical orbits similar to those of comets. And there are planets orbiting their stars in the wrong direction. This second discovery is particularly difficult to explain, given that planets are believed to form from gas and dust orbiting in the same direction around a newborn sun. No one yet knows whether the unusualness of our solar system has anything to do with the human race noticing it. 19. Large-scale structures of the universe. Considering only the largest structures, the universe appears to consist of filaments, voids, superclusters, galaxy groups, and clusters. By combining galaxy groups and clusters, we reveal superclusters. Some superclusters form part of the walls that are also part of the filaments. Large empty areas are called voids. Additionally, the fact that some parts of the universe are clustered and others are empty is consistent with CMBR measurements, which show slight changes in temperature in the early stages of its development. 20. Stellar recycling. Elements heavier than helium, such as carbon, oxygen, and iron, are formed in the cores of massive stars during their lifetimes and are released into space when these stars explode as supernova. These elements then become the building blocks of new stars, planets, and life. So, how are other elements formed? We don't know exactly how other elements are formed, but it is predicted that these elements may have formed in places that produce high energy and high pressure, such as neutron stars or black holes. 21. Photon journey. A photon, a particle of light, can take thousands of years to travel from the sun's core to its surface, but it only takes about 8 minutes to reach Earth. 22. Oldest light. The light from the cosmic microwave background that we observe today is approximately 13.8 billion years old, dating back to just 380,000 years after the Big Bang. 23. Gravitational lens. Large objects such as galaxies can bend and distort light from objects behind them, acting as cosmic lenses. This phenomenon, called gravitational lensing, can reveal distant galaxies and dark matter. 24. Voyager golden record. These are golden records found on the Voyager 1 and Voyager 2 spacecraft, containing sounds and images from Earth, aiming to introduce our planet to potential extraterrestrial civilizations. 25. Pulsar clocks. Pulsars are incredibly accurate natural clocks. Some pulsars spin with incredible regularity, hundreds of times per second, making them useful in testing the theory of relativity. 26. Hawking radiation. Black holes can emit radiation called Hawking radiation due to quantum effects near their event horizon. Over time, this radiation can lead to the slow evaporation of the black hole. 27. Cold boomerang. The Boomerang Nebula is one of the coldest places in the universe, where temperatures drop to just 1 degree below absolute zero, -458 degrees Fahrenheit or -272 degrees Celsius. 28. Shrinking of the Moon. The Moon is gradually shrinking due to the cooling of its interior. This causes its surface to wrinkle and create moonquakes. Also, as additional information, astronauts returning from the Moon say that the Moon smells like gunpowder. 29. Black holes. At one point, these intergalactic vacuum cleaners were actually supermassive stars. When one of these stars dies, its often gaseous outer layers explode and the core collapses into an extremely small and dense sphere. For example, imagine trying to pick up a tennis ball that contains the entire mass of the Sun. The immediate effect of this astronomically high density would be an incredibly strong gravitational field. To escape any gravitational field, you need to move faster than something known as escape velocity. Spacecraft on Earth achieve this by reaching speeds of approximately 7 miles per second, but in some collapsed stars they must reach speeds faster than 186,000 miles per second, which is more than the universal speed limit. This means nothing can escape, not even light. 30. If there was air in space through which sound could propagate, the Sun would emit a deafening sound of 290 dB from its surface. This is so loud that it almost exceeds sound and becomes a pressure wave. But on the Earth's surface, this sound would be about 120 dB, which is as loud as standing a few meters away from an active breaker. The scary part is that if the Sun suddenly disappeared, not only would it take a full 8 minutes for us to notice the lack of sunlight or gravity, but it would still be going on because the speed of sound is relatively slow. Bonus: Andromeda is the closest major galaxy to the Milky Way, approximately 2.5 million light-years away. It is hurtling towards our galaxy at approximately 250,000 miles per hour, fast enough to travel from the Earth to the Moon in an hour, and is expected to collide with the Milky Way within 4 billion years. Yes, we saw interesting facts about 30 universes. Actually, my number one fact in this video was the fact about water. Don't forget to mention your favorite fact in the comments. Don't forget to like and subscribe to support the channel. Thanks for watching. Bye.